All right, Power Series Day 1, here we go.
A particularly important skill to develop for the AP exam, other than checking that you're in radian mode, is to represent certain types of rational functions as a geometric series. Rather than producing the power series using Taylor's rule, you will want to develop the series by manipulating a geometric series, or in some cases using long division. First, we'll do a quick review of geometric series. Geometric series are formed by multiplying by a common ratio r. Suppose I told you to start with ace of 1 equals 2 and to let r equals 3. What geometric series would you write? What would the sum be in each case?
All right, fantastic. So if I were to actually write my nth term, and I'd start at 2, I'd have 2, and then my ratio would be what? 3, but I'd do it to a power of n minus 1. So now we would have that as our a sub n. However, can we find that sum? Can we actually find the sum of that? No. Okay, the sum would actually be infinity because my r would be what? Greater than 1. And so that sum actually diverges. All right, so let's look at part 2 now. And so if I were to have this ratio of -3, I'd end up having my first term of 2. And then what would be my next term? My ratio is -3, so I'm multiplying each term by -3. So what would be my next term? -6. Then what would be my next term? 18. Then my next term would be what? -54. However, if I were to actually build that summation, that would have 2 times -3 to the power of n. And so that's actually my general term. And so my summation of it would be n equals 0, and I'd go to infinity of 2 times -3 to the power of n. However, what do we know that does? That diverges. Tell me why. The absolute value of r is greater than 1. All right, and so now let's do it again, but now let's say my first term is 1 and my ratio is x. This is where it's at. Here we go. And so now my first term would be 1 plus what's my next term? X plus what's my next term? X squared. My next term is x cubed. And so then what is my general term? It'd be x to the power of n. And so my summation would be n equals 0 to infinity of x to the power of n. And so if I were to actually write out my summation of this, how do I actually find a summation given geometric? It would be what? A sub 1 over 1 minus r. And so if I were to actually find the actual summation of this, what would be my first term? 1. It would be 1 over 1 minus, what's my ratio? X. And so we actually need to figure out what that x is, but that's actually my summation to infinity on that. All right, whatever that x might be.
Find the power series for 1 over 1 minus x centered at c equals 0 by A using Taylor's.
All right, let's do that first. All right, so let's go old school. And so we have f of x is equal to 1 over 1 minus x. A lot of the times will think of that as 1 minus x to the power of -1 just to save some time on this. And so if it's centered at 0, it's a what kind of, anyway? It's a Maclaurin. And so when I center it at 0, I get f of 0, which happens to be what? Just 1. And then f prime. So what's f prime now? There it is. It's 1 minus x to the -2, because what happens to my negatives? They cancel. And so now when I substitute in 0, guess what I get? So f prime of 0 would be 1 still. And then f double prime of x. What's my f double prime now? What's out front though? A 2. All right. All right, and so then f double prime of 0 would happen to be what? 2. And then, let's keep going. Let's do one more. F triple prime of x would happen to be what? 6 over 1 minus x to the power of 4. And so f triple prime of 0 is 6. All right. And so when I build this, I would end up with 1 plus x plus what? 2 over 2 factorial, and then x
Minus
squared, and then plus 6 over 3 factorial x cubed, plus dot, dot, dot. Plus, what would be my general term? Does anybody see what's happening here? Bless you. It's going, so all those coefficients are going to what? 1. And so what's my general term? It's just x to the power of n. That's convenient. All right, let's do part B now. Let's look at part B. Woody.
Manipulating a geometric series.
All right, beautiful. That's what I like to do. That's what I like to do. So if I have 1 over 1 minus r, this is in the form of a sub 1 over 1 minus r. Okay, 1 over 1 minus x is in the form of a sub 1 over 1 minus r. This is where we're working with. This is the geometric power series. And so guess what my first term is? 1. And so my first term is going to be 1. Plus, what is my ratio? X. And so guess what 1 is being multiplied by? X. And so now I'd have 1 plus x squared plus x cubed. Do you see how it's the same thing? All right. And so that's actually what's happening. All right. And then part C, you can actually still do what? Use long division. All right, so let's do long division. Here we go. All right, sometimes it's useful. This case, I'm just trying to prove a point. And so we're going to divide 1 by 1 minus x. We're going to divide 1 by 1 minus x. All right, and so how do I get to 1? I multiply everything by what? 1. And so then I'd end up with 1 minus x. However, what would I highly suggest you do? Remember, we distribute the negative. And so then I add straight down. What am I left with? X. I'm left with x. And so then how do I get from 1 to x? I multiply by what? X. And so now I'd have x minus x squared. And so then I'd distribute the negative. So now I go and so then what am I left with? X squared. Well, how do I get from 1 to x squared? I'm going to have a plus x squared. Do we see the pattern? All right. And so guess what? It's still going to be x to the power of n is my general. All right. And so there is the different ways to Tampa on how we're working with things. So we already knew Taylor's rule in part A. We're going to be working with part B. However, guess what you can do to all of them? You can also long divide, but ain't nobody got time for that usually. All right, so mostly B is our best way to do it. All right, so anyway, here we go. We're going to find the interval of convergence without using the ratio test. Here we go. And so now I want to do an interval of convergence. Well, what test what test can I actually use here? I can use the root test. And so then I'm left with the limit as n approaches infinity of the nth root of x to the power of n, which is actually what? X, absolute value x, which what do we want it to be? Less than 1. We want it to be less than 1 because it's actually a geometric power series. It's a ratio. And so what am I in between? What is my radius of convergence first? It's 1. And what would be my interval of convergence? It'd be -1 to 1. All right. A quick little test is on geometric power series, the endpoints always fail. All right. Just a quick trip. So it actually always fails. If you think about it, if I were to actually back substitute it in my general term, if I substitute in -1, guess what it does? It oscillates. If I substitute in 1, guess what it does? It goes to 1. And so it's going to fail on those. But if I substitute in like 1/2, guess what it does? It converges by GST. All right, so the endpoints actually fail always on geometric power series. All right, so on this one, we're going to find a power series for 1 over 1 plus x. All right, so on this one, is it in the form of a sub 1 over 1 minus r? Not yet, but I can manipulate it, can't we? Can't we, Tatum? Yeah, we're good at manipulating. And so what can we do? How can I think of 1 plus x? This is really what? 1 minus a negative x. Exactly. And so now what's my a sub 1? It's still 1. And so guess what my first term is? 1. However, my second term, I get there by multiplying by what? Negative x. So my second term is minus x. And then what? Plus x squared. Then what? Minus x cubed. All right, and then it said first 4 non-zero, so we got that. And so let's figure out my general now. So plus dot dot dot, and then plus. And then a lot of the times we can do this pretty quickly by using your first term, which is 1, and then your ratio, which is negative x to the power of n. And so that's really how we can do it quickly. However, they don't usually look like that. And so what would they actually look like on this one? I think it would probably look like negative 1 to the n and then x to the n. All right. However, it is actually the same because it's a sub 1 and then your r to the power of n. All right. Let's kind of manipulate it. So is it in the form of a sub 1 over 1 minus r? Not quite yet, but it's really close. And so, Tatum, how can we manipulate this?
X over 1 minus negative x.
Love it. All right, so that's where we're at. And so on this one, my first term would be what? X. I'm just going to explicitly write this one out. And then my r would be what? Negative x. All right. And so my first term is x. And then what's my second term? Negative x squared. And then what's my next term? Positive x cubed. And then what's my next term? Minus x to the fourth. And then plus dot dot dot. And then what is my general? What is my general on this one? Okay, so if you did it really quick, it would just be the first term of x and then times negative x to the power of n, yeah? However, that's not usually how it's going to be looking like, and so how could we rewrite that? It'd be negative 1 to the power of n, and then x to the power of what? N plus 1. There we go. Perfect. Plus dot dot dot. All right, and so there is our general term on that one. We need to find the interval of convergence. I don't know if I did that on the last one. We're going to do it on this one. So how do I find the interval of convergence? We're going to use ratio test. So now we have the limit as n approaches infinity of absolute value of what? My next term. And so what is my next term? X to the power of n plus 2 over x to the power of n plus 1. And so that goes to what? Absolute value x, which I want to be what? Less than 1. And so now, what is my interval of convergence? It'd be negative 1 to 1. All right. Now, could you test the endpoints? Yes. However, on geometric power series, they always fail. All right. Let's do another one. And so on example 5, is this in the good form that we need it? Yeah, this one's really good. This one's nice. And so what's my first term? 1. And guess what my ratio is? It's not negative x squared, but just what? Just x squared. And so then my first term is 1. And then what? Plus x squared. Then what? And then what? Plus dot dot dot. All right. And then what is my general term here? X to the 2n. All right. And so now that's technically like the summation of x to the 2n from 0 to infinity, but we're going to find the interval of convergence here. And so now, what test could we use? I would personally use root, all right, because it's an nth root. We might as well just use root. And so now I have a limit as n approaches infinity of absolute value, an nth root of x to the 2n. And so now what are we left with? X squared. All right. And I still want that to be what? Less than 1. And so, anyway, what is my interval of convergence still? -1 to 1. So we had a question on if we want to actually test these endpoints. So let's do it. So we're going to test x equals -1. And so now we'd have the summation of, when I substitute in -1 right here for my general, I would have what? -1 to the power of 2n. So what does that go to? That'd be really like -1 to the power of 2n. So does it actually go to 0? If I take a limit to infinity, does it go to 0? No. So what does it do? It diverges by nth. It diverges by nth. All right. If I were to test x equals 1, guess what we would get again? It diverges by nth. All right. And it has to do with that geometric power series thing, because it's not going to be less than 1.
Okay.
That
so
ratio. All right, so let's look at this one now. Is this in our form that we want it in?
Yeah.
Yes, okay. And so what's my a sub 1? 1. And then what's my r? 2x. Love that. And so now, what's my first term? 1. And then plus what? 2x. And then plus what? 4x squared. And then what? 8x cubed. All right. Sometimes, guys, what I do on these is I actually like go like 2x, and then I'm like 2x quantity squared, and then I'm like 2x quantity cubed. All right. It kind of helps me like organize my thoughts, because I need to get my general. And so then what would be my general? The quantity of what? 2x to the power of n. And so I can think of that as like 2 to the power of n and x to the power of n. And so I don't know. Sometimes in my head, I kind of like to do just like this, because do you have to simplify them? If it's free response, do we have to simplify? Not at all. And so sometimes I like to leave them unsimplified. All right, and so there's our first 4. And so we're going to find the interval of convergence. What are we going to use? Let's root it out. So I'm going to do a limit as n approaches infinity of the nth root of what? 2x to the power of n. And what are we left with? Absolute value of 2x, which I want to be what? Less than 1. And so this is really absolute value of x, which is less than what? 1/2. And so, again, I'm centered at 0, but now what's my interval of convergence? -1/2 to +1/2. All right. All right, so now we have 1 over 4 plus x. All right. Is this in the form that I need it to be? Not yet. Not yet. And so, not yeti. That's good. That's good. All right. And so, what do I want this 4 to be, by the way? I need that to be a 1. I need that to be a 1. And so, what do I do to get that to be a 1? I divide everything by what? 4. Or multiply everything by what? 1/4. All right. And so, that's going to make my 1 up top to be what? 1/4. And then I have it over what? 1 plus what? X to the 4th. Now, I think, Ethan, you were on the right track. I don't have it as 1 minus r yet. And so I really want to think of this as what? 1/4 over 1 minus a negative x over 4. Okay? So I had to manipulate a couple things there. And so now am I in that form of a sub 1 over 1 minus r? C. All right. All right. And so now what's my first term, Socks? 1/4. And then what's my next term? Minus x over 4 squared. All right. And then what's my next term? Plus x squared over 4 cubed. Do you see why I'm doing this? Because now I'm going to the next one, and it's going to make my general term a lot easier to find. And so then minus what? x cubed over 4 to the 4th plus dot, dot, dot. Now we get our general. And so what is my general here? X to the power of n, but it's over what? 4 to the power of n plus 1. Exactly. Very good. All right. And so now we need to find our interval of convergence. And so let's do a limit as n approaches infinity. What test would I personally use on this one? I'd use ratio. I agree. And so now we'd have x to the n plus 1 over 4 to the power of n plus 2. Very good. And then times 4 to the n plus 1 over x to the n. All right. And so now what am I left with up top? An x over 4, which happens to be what? Less than 1. And so what do I want it to actually be? Absolute value of x is less than 4. So what's my radius? 4. And so what's my interval of convergence? Negative 4 to 4. Sorry, I almost got struck. Thank you for Emma saving me. What happens to this thing? It does what? It alternates. How should we take care of that? We got a negative 1 to the power of what up here? N. All right. Now I feel good. Now I feel good. Thank you. I'm sorry, Alex.
Sometimes we cannot center our function at x equals 0. In this case, we must try to rewrite our function with the new center showing. Example 8. Find a power series that represents 1 over x centered at c equals 1. Then find the interval of convergence. Include the first 4 non-zero terms and the general term.
All right, so now we have to manipulate further, okay? Today we're not going to manipulate too much. However, we are going to manipulate a little bit. And so right now, this 1 over x is actually centered at what? It's actually 0. It's 0. But I actually need to center it at what? 1. And so what I'm going to do is now I'm going to have x minus 1 down there. Does that make sense? However, if I subtracted 1 in my denominator, math's an equal opportunity sport, so what should I do? Nope. I need to add 1 on the bottom. Okay? Okay. That was close. All right. And so if I subtract 1 on my denominator, I also need to add 1 on my denominator. Yes? Okay, cool. However, is this in the form of a sub 1 over 1 minus r? Not yet, but it's really close. All right, we're going to manipulate more on Monday. All right, but anyway, so how could I manipulate this one to get it in that form I need? 1 over 1 minus a negative quantity x minus 1. All right. And so now, what is my a sub 1? 1. And then what's my r? Negative quantity x minus 1. All right. And so now what's my first term? 1. And then minus x minus 1. And then what? Plus
X minus 1 quantity squared.
love it. And then minus x minus 1 quantity cubed. All right. So there's first 4 non-zeros. And then plus dot, dot, dot. All right, hopefully we don't forget the alternating part this time. And so now we'd have what? Negative 1 to the power of n, and then I'd have x minus 1 to the power of n, and then plus dot, dot, dot. All right, and so now let's do our interval of convergence. I'm personally going to use root test, and so now I have what? The limit as n approaches infinity of the nth root of x minus 1 to the n. And so now what am I left with? Absolute value of x minus 1. And what do I want that to be? Less than 1. And so now where's this thing centered at? 1. And so now I'm going to add and subtract 1 to 1. And so then I get my interval of convergence is 0 to 2. 11.4 PS2, numbers 1 through 5. And what do we have to say for Alex? We're going to say what? Arctan. All right.